It's really easy to make logic errors when you're writing loops. But we can avoid a lot of these simple errors if we just have a good understanding of the basic structure of a loop. Loops typically have four parts. We start usually with initializing statements, which is, statements that initialize variables that we're going to use in the loop. We probably have a terminating condition, which is the condition that we test every time we go through the loop, basically to determine if we're going to do another pass afterward. Then we'd, of course, have body statements, which are the things that we do every time the loop runs, assuming that we pass the condition. And finally, we'd have update statements, which are usually at the bottom of a loop, and they basically change the values of the variables that we're using to test in the terminating condition. If you're careless, you can introduce logic errors in any of these parts. So to explore this, let's start by looking at a pretty simple but correct while loop. And then we're going to show a couple of revised versions, each of which has a different logical error. So here's the correct version. We're calculating the product of all the odd integers from 1 to 100. So you can see we start with a variable product, which has the value 1, and we're starting our loop at I equals 3. As long as I is less than or equal to 100, we are multiplying product by the current value of I and storing that back into product, and then incrementing I by 2. Finally, at the end, when we exit the loop, we print the product. That's correct. That works. Okay. So first potential error, maybe you make a mistake in the initializing statements. So maybe you forgot to initialize the variable product so it gets its default value 0. Here, that's what's happening with product. Product starts as 0, and every time we multiply product by I, we get 0 over and over again. As you can probably predict, at the end when we print out our final value, you're going to see 0 instead of the actual number. In this version, we've got a mistake in the terminating condition, in that while I is less than 99. We typically call this an off by 1 error, and it happens whenever a loop goes around just one too many or one too few times. This is really, really common, and it's often pretty hard to actually figure out that that's what's going on. Here, it's actually pretty obvious, though, what's happening. We can see that our loop doesn't run for I equals 99, even though I should be part of this product. Here's another common kind of mistake we might find in the terminating condition. You can see here our condition is while I is not equal to 100. We start with I equals 3, and we keep adding 2 over and over again. So as you can see, I is going to take the values 97, 99, and then 101. It's never going to equal exactly 100. So our condition never gets proven false. We call this an infinite loop. We blow right past our condition here. Anytime a program responds a lot slower than you'd expect, you might expect that it's caught in an infinite loop somewhere. You probably want to stop your program and figure out where exactly that's happening. Here's another one. This is in the body of the loop, and it's pretty obvious because I'm pointing it out to you, but often errors like this can actually be kind of hard to figure out when you're in the midst of one. Here you can see we're adding rather than multiplying the values. So yeah, that's a problem. You might have a mistake in the update statement as well. I mean, here it's in the wrong place. So rather than multiplying 3 times 5 times 7 times and so on, we actually start here with 5 because immediately when we enter the loop the first time, we increment before doing our multiplication. That's a problem. We're going to get the wrong number. Okay, now last of all, this is one of the trickiest to people who are new to programming. Floating point numbers, as we've discussed before, floating point numbers are imprecise. Doubles in Java have about 18 decimal digits of precision. So that's pretty good, but it's not perfect. And if you're not careful, it can lead to some sort of unexpected errors. Think about these lines of code, which seem like they're free of any sort of logical errors, but we still get an infinite loop. Here we're just saying, start my double variable x at 0. As long as x does not equal 1, add 0.1 to it. So it should be pretty straightforward, right? And we're printing out x every time we go through the loop. We would expect something that looks like this: 0, 0.1, 0.2, 0.3, 0.4, 0.5, and so on, all the way until we get to 1.0. Actually, we end up with this weird output and an infinite loop. What gives? So maybe it's helpful to think about this. The decimal representation of 1/3 is 0.333333, and so on. The 3's go on forever. So any finite representation we have of a number like 1/3 in decimal form, it's not exact. The same sort of thing is happening here. When 1/5 is represented in binary as a double, well, it's also not exact. So x never equals exactly 1.0, and the loop never actually terminates. Here's how we might fix it. We use some tiny delta value. Here it's 0.01, and it's less than the increment we're adding by. And we just say as long as x is less than or equal to 1.0 plus that delta. And that little bit of buffer, along with the use of less than or equal to rather than not equal to, is enough to make sure that we don't blow past our condition and we don't get stuck in an infinite loop. The code now works right as long as that delta is less than the increment, in this case 0.1. So you can see the new output here. So to sum up, if you've written a loop and you think there's some kind of logic error, you want to read through your code and figure out, whether or not you've made a mistake with variables being initialized correctly before you enter the loop, making sure that you have a good terminating condition that's going to stop the loop at the right time, making sure that everything in the body is correct and working the way you intended to, and finally making sure that the update statements are in the right place and they're behaving the way you had intended. It's also a good idea to try to restrict yourself, if you're doing arithmetic in your loops, to use less than or equal to, or greater than or equal to, rather than equals or not equals, because oftentimes it's very, very easy to just blow right past equals or not equals conditions. And if you can't find out exactly what's going wrong just by reading through your code, then it might be time to whip out the Eclipse debugger, or to add some illuminating print statements to dump the values of key variables to the terminal, to the console window. You might want to put those print statements right after you initialize a variable, inside a loop at the top, so you can see what everything looks like right when you enter the loop every time, or maybe at the bottom of the loop so you can see what the effects of the loop were. Maybe you'll see that some variables don't have the values you would have expected, or they're not changing in the way you'd have expected, and then you've got a good place to start your quest to fix your bug. Before you close up shop, take a look at these two loops and make sure you can ID the errors in them. That's it for today.